So, so hi, welcome to June 2023. This is a paper two, so calculators are allowed. The first question, and we went through this formula sheet in the last time that we did a paper, in the last paper. So we have this one here. Now this is calculator stuff, but yeah, I mean it might actually be quicker to do it by hand, right? You know it's BOD mass, so you have to do the fractions first, the multiplication first, sorry. So you know 7 5s are 35. And what you're gonna have here? 3 into 4 is 12. And 3 3s are 9. So that means in the brackets here, 4 multiplied by 1 is 4 over 5 3s are 15. And then you have minus 2 over 3 plus 5 over 6. Now, I see here, oh great, somebody had to be passing blasting music when I recorded, right? You all hear that, by the way? I don't know if you heard that. All right. So in this situation, I mean, yeah, you could punch it in your calculator, but let me just say you're left without her. And that happened to me once, forget my calculator home kind of thing. It does happen, right? So I'll realize I could do an equivalent fraction here for either the 6 or the 15. Let me do it for the 15, because 15 kind of big and ugly. If we do it for the 6, we'll have 6 and 15, I guess. So all right, so 5 3s are 15, and then 5 2s are 10, so that'll be 10 over 15 minus 4 over 15. And over here we'll have 5 over 6 plus, and I kind of getting fed up now in terms of, let's just use the calculator, right? 10 minus 4 is 6 over 15, and yeah, I'll switch. 5 over 6 plus 6 over 15, yeah, is 1 and 7 over 30. That's what the calculator says. Now, in this case, I did choose to go to my calculator because of time. Yeah. Calculate that. So I will go in my calculator. You had to be careful about things like this. So what I would do is, your second function is a calculator thing, and I'll show you on the calculator just now. But imagine second function, square root, and then what you should do is, after second function, square root, please brackets, right? And then you type your 1, and then your minus, and then please do this bracket again for the cos 37. When you do this bracket, you could put your square here and then put another bracket to close off the entire thing, so that the calculator will know that all of this is under the square, right? So let me try it. Let me see. All right, let me see if it works. So second function, and you should try this. I will go brackets 1 minus brackets the cos of 37 close brackets square. Yeah, that did work, with a bracket on the outside. Let me see if that works. All right, so I got, anybody want to tell me what they got? Sibiria, what you get for this?
I got 0.602.
0.2, yes, that's what I got as well. Now, if you're not confident about a calculator game, you could very well just do it piece by piece. That is, type in the cos of 37, write that down, and then square it. And then when you get the square that, do 1 minus that, and then take the square root of the answer. If you're not confident, because with the calculator, if you miss one of these brackets, bro, that is it for you, right? And any questions, please? Yes, it is recording, but you can stop me at any time, yeah? Write this in standard form. Well, we know in standard form we want a number that will be between 1 and 10. So it'll have to be 5.27. We can't have 52.7 and we can't have 0.5, right? So this is a number between 1 and 10. We're going to have to multiply that by 10 to the something. So 5, if the point was here, the point would have to move this direction, which is a negative, and it'll have to move 1, 2, 3. So it'll be 5.27 by 10 to the negative 3. I hate consumer arithmetic. This is where I had to start to yawn. Harish works at a call center for 35 hours each week. He is paid an hourly rate of that. So let me see. 35 hours multiplied by 11.2. And remember that whole thing about or you could help me with calculations and tell me what you get, because that is actually kind of speed it up, you know. I get 392, so it's $392. My boy working for a week, works at a call center for 35 hours a week. Yes, okay. Calculate the amount of money he earns in a 4-week period. So this is per week, and then you multiply that by 4 to give you
1568.
Thank you very much. 1568. I see somebody do it. You do the paper. In a certain week, Harish works 8 hours overtime. Overtime hours are paid at 1.5 times the usual rate. So that means 1.5, 1, 2, 2, and 1 is 3. So that is 3 on 2 literally times 11 per hour. So that gives me 3 on 2 is 1680. So my boy getting paid 1680 if he work overtime. You see how they just trap here. All of these things are important because all of these things are actually the workings of the slave system. This is how they just trap you. Work overtime, you work extra, you get more. You know what I mean? Right? So find the total amount of money Harish is paid for that week. So how much you work 8 hours more overtime. So that means that if this is per hour, then this multiplied by 8 will give me $134 he make overtime. And so therefore, how much he worked for here? 15. Oh, and don't forget your dollar signs, please. 1568. Therefore, 1568 plus 134.4 is 1702. And if I make any calculator errors, please let me know, for all of you who did the questions. Leela, how you doing? You all right?
Yes, sir.
I really pray for all you that all you get. I mean, I guess consumer arithmetic is, I just find it boring, but it is easy. So I hope that you get, a longer consumer arithmetic question, because it is just easy marks. The annoying thing is you just have to read all kind of nonsense that, like Harish and all, I don't know. Simplify this. All right, we reach the algebra, right? 4 into 4 is 1. 4 4s are 16. The x's will actually be gone, right? 5 into 5 is 1. 5 3s are 15. So you have 3, and then 1 times 4 is 4. So 3 over 4 is the answer there. Solve the inequality. And please remember, you could stop me anytime, right? 12 minus 4m is less than or equal to that. All right, so 12 minus 4m is less than or equal to 5 minus 8m. Now I am going to take this minus 8m and throw it across. It's going to become plus 8m. This does nothing to your sine though, because what we're actually doing is we actually add in 8m on both sides. That's what we're doing. So the sine is only affected when you're multiplying and dividing by a negative. So just remember, throwing this across means you're actually adding. So the sign is okay. Minus 4m, and this will be a plus 12, is less than or equal to 5. I could throw the 12 across and nothing will happen to the sign either. So 8 minus 4 is 4m, is less than or equal to 5 minus 12. 4m is less than or equal. 5 minus 12 is like what, 7? Is 7. That's a weird number. Negative 7. And you're not throwing anything across here. The negative is on this side. I am actually throwing across a positive, so the sign remains where it is. Negative 7 over 4. Now there are other ways that you could have done it. Like if you had thrown the negative 4m across on this side instead, then you would have ended up with a negative that you would have had to throw across, and there is a chance you could have ended up having to flip the sign because of that. Right? So if you find that you get the same answer but you had to flip the sign, because there are other ways to do it, right? Yes. The diagram below shows a compound shape, LMNPQR. Okay. All right, let me check. Let me see. LM N, P, Q, R, and I see in some distances here. All right. The lengths of the diagram, which are written in terms of x, are in centimeters. Thank you very much for telling me that. Find an expression in terms of x for the length PQ. PQ is here. And that would be this entire distance, which is 3x, minus this distance, which is x plus 3. So PQ would be equal to 3x minus x plus 3. And remember, you're minusing this quantity. This is where you could make a mistake and get it wrong. Because if you put 3x minus x plus 3, you might just think that the x alone is minus. But no, it is this bucket. So this bucket minus this bucket, which is this. So that means you really have 3x minus, in brackets, x plus 3. And so I hope nobody made that mistake, because that means you'll really have 3x minus x minus 3. And 3x minus x is 2x minus 3. So you could have make a mistake real easy with that one. Right? Careful yourself. And then, yeah, that's PQ. RQ. RQ is this length over here. I'll go do it in a different color. Please do not use red on your paper. Don't even carry a red ink in the exam. Just don't do it, right? Don't do it. I just use a different color here. So RQ is what I want. That means that I'll have to take this long one, which is this bucket with 4x minus 5, and I'll have to minus this distance here, which is x plus 1. So 4x minus 5 minus x plus 1. Same thing. This bucket, 4x minus 5, minus this bucket, x plus 1. Right? So that'll give you 4x minus 5 minus x minus 1. So 4x minus x is 3x, and minus 5 minus 1 is minus 6. So this is 3x minus 6. This is a fun question. I like this question. But you could see how you could get a chain up real easy if you don't use your brackets. Yeah. Given the total area of the shape is that, show that, okay, x squared plus x minus 72. So I want to find the area of the shape, and I know the area of the shape is this. So what would be the area of this thing now? The area of this thing would be the area of this guy. So that. All right, let me call that A. Yeah, and so that the area of that is length times breadth, right? So the area of A is your length, 4x minus 5, multiply by your breadth, x plus 3. All right, I'm gonna leave that there. I have to add that to the area of this. And the area of this, which it looking squarish, but it's not a square because, you know, this is 2x minus 3. So I have to add that to the area of B, which is this, which is the area of x plus 1 into 2x minus 3. So we basically have a convoluted distributive law question here. All right, so we had to do with distributive law. So 4x times x is 4x squared. 4x times 3 is 4 3s are 12x. Negative 5 times x is negative 5x. Negative 5 times 3 is negative 15. All of that in our brackets. That is one bucket. You see how brackets just come in handy, and you're adding that to this. So this is going to be x times 2x is 2x squared. X times negative 3 is negative 3x. 1 times 2x is plus 2x, and then 1 times negative 3 is minus 3. It's easy, but it's just real work. You know, they're making me work here, my brain kind of fogging up. 12 minus 5 is 7, so I have a 7x here. I have a minus 15 here. I have a 4x squared plus here. This plus sign doesn't really do anything. I'll just put the plus sign, and this will remain the same because plus doesn't change anything really, you know. So so that means this will still be plus 2x squared minus 3x plus 2x minus 3. So I could easily remove these brackets and nothing is affected because this is an addition sign, right? Now I have 4x squared plus 2x squared is 6x squared. I have 7x. Ooh, look, I didn't boil this down. Minus 3 plus 2 is minus x. All right, so that's a minus x there. So 7x minus x is plus 6x. And then minus 15 minus 3 is minus 18. Now this is the area, and you can see is a quadratic that we got to be the area when we boil down everything. And obviously you could divide by 6, but remember, before we divide by 6, they tell us that the area of the shape is 414. I hope 414 could divide by 6. If it doesn't, I will be very, very sad. Can it? 400. Yep. Interesting. So now I could just divide everything by 6 to get x squared plus x minus 6 3s are 18 is equal to 69 on this side. And if I bring this across, because what did they say? Minus 72 is equal to 0. Yeah, that is what they want. So if I bring this across, I'll get x squared plus x minus 3 minus 69 is equal to 0, which implies x squared plus x minus 72 is equal to 0, which is the proof. So this one was easy. It was just a matter of the distributive law and being the distributive law over here, and then we dealing with the associative law over here in terms of knowing that you have to add your x squareds, your x to the power 1, and then your numbers, essentially, right? The diagram below shows a semicircle, yay, with a diameter AC. So I have AC here. B is a point on the circumference where AB is equal to BC. So I see we have an isosceles triangle. This immediately tells me that these two angles will be equal. It also tells me that this is a semicircle. So this is the angle in a semicircle. Angles in a semicircle is 90 degrees. So you see how circle theory coming in here, even though there's not really a circle theory question, right? Somebody, let me see, let me ask for an answer here. Somebody could tell me, let me see. And feel free to get it wrong. I just kind of want to see something. State the geometrical name of the line AB. What is the geometrical name for the line AB? There's a 1 mark. So let me see. Anybody who do it, or anybody who didn't do it, thank you very much. Like a boss. This is a chord, right? And this chord divides into the major segment and the minor segment, and these two are alternate segments. So so nice. Find the value of the radius of the circle. How much marks is this, boy? 3 marks. The radius of the circle is from the middle here. So I had to find the length AC and just divide it by 2. How am I going to find the length AC? This is 8.2 centimeters here. I know this is 90 degrees. Oh, well, if this is 90 degrees and these two are equal, that means, remember, the angles in a triangle are 180 degrees. So 180 minus 90 means these two are 90. And if these two are equal and these two add up to 90, that means that this is 45 and this is 45. And so now maybe I could use trigonometry. All right, Zara, what you do here? Siberia, what you do here? Huh?
Pythagoras theorem.
Oh, yeah. Yeah, you could use trigonometry, but yes, you could use Pythagoras. Pythagoras is definitely the easier route here. Trigonometry would I get to you too, as well. But yeah, Pythagoras here, you do have a right angle triangle. This is the hypotenuse. Excellent job. All right, we gonna go the Pythagoras route. That is definitely the easier way. Let's call this side C. No, well, C is always the hypotenuse. So we'll call this A and B, even though that's not how you label triangles, right? So A squared plus B squared equals C squared. So C squared is equal to, this is 8.2 squared plus another 8.2 squared. So C squared is, what I work out to be? 134.48. C is the root of 134.48. Let me know if I punched in anything wrong, eh? So the square root of the answer is 11.5. 11.5. Did I say anything about 11.6 really? Centimeters. Alright, so find the value of the radius of the circle. Therefore, radius is 11.6 divided by 2, which is 5 Here now, this is a beautiful question, right? And let me see, anybody had any ideas for this one? This is such a beautiful question, right? Zara, you had any ideas for this? Sabira, you had any ideas for this? Anybody who did the paper? Anya, you did the paper? This question it really is, sometimes you just see some crappy questions in CSEC, but this is a beautiful question. This question requires you to remember one of those tiny little rules. I hate when it changes color. I had to stop it from doing that. But one of the tiny little rules, right? All right, so each interior angle of a polygon is 160 degrees. Calculate the number of sides of this polygon. So that means that a polygon is a straight-sided figure, like a triangle or a square. And these are the interior angles. And the interior angles just add up to different things, right? So for polygons, the more sides you have is the more the interior angles will add up, right? So, a pentagon, I think, is like, the interior angles is like 540 degrees, the sum of it. We did a whole table, But this question is not about interior angles. This question is about exterior angles. The exterior angles are when you extend, that is one exterior angle. This is another one, and then you extend, this is another one. So this question is about the exteriors. Why is this question about the exteriors? Well, you see, the interior angles don't have a limit. Yeah, the more sides you have is the more, the sum will just become bigger and bigger. 1,028 degrees. If the more sides you add, but the exterior angles. Anybody could tell me? The exterior angles for every polygon, even if it's 100-sided figure, the exterior angles, the summation. When you add up all the exterior angles, the summation of all exterior angles will always add up to 360 degrees. So adding up your exterior angles, no matter the side of the polygon. So this is a triangle. Well, if you add all of these exterior angles up, you're going to get 360. This here is a quadrilateral. If you add all of these exteriors up, you're going to get 360. This is a pentagram. You add all of these exteriors up, you're going to get 360. So imagine we have a shape here where the interior angle is 160 degrees. So that means that this shape come in so, and then it go in so. And this here is 160 degrees. And I don't know, because the interior angles, each interior angle of a regular means that all of the sides are equal and all of the angles are equal. So that means that each one of these things gonna be 160 degrees, 100. I don't know how much sides this thing gonna have, right? I can't tell from the internal angles, but if you notice, if this is 160, the angle in a straight line, right? This is your exterior angle. So the exterior angles, for every one of the exterior angles, are going to be 20 degrees. Yeah? So imagine now, we're looking back at this triangle here. Imagine how this exterior, this is three sides or three exterior angles, because it have three sides, so it'll have three exterior angles, right? So it's 3 times whatever the exterior angle is, right? 3 times whatever the exterior angle is will give you 360. Yeah. In this case, And this is because this is 3 sides. In this case, is 4 sides. So 4 times whatever the exterior angle is in this case will give you 360. In this case, 5 times whatever the exterior angle will give you 360. So in this case, we don't know how much sides, so we'll call it n. N multiply by the exterior angle. So n amount of exterior angles must be 360 degrees. Guess what? We know the exterior angle. N times the exterior angle 20 is 360. So the amount of sides this shape will have is 360 divided by 20. 18 sides. The diagram below shows a trapezium A. Draw on a square grid. Drawn on a square grid. Okay, I'm reading real off today. On the diagram above, draw the image of A after it undergoes a reflection in the line. X is equal to -1. Label this A prime. So the line X is equal to -1 is this line. And so a reflection in that line, you have 2 away. So 1, 2, it'll be here. I'll have to come up here. I'll have to go like this, like this, like this. And that will be A prime. A translation with a vector 4, -7, A double prime. So is it A? Draw the image of A after it undergoes. Number 1, a reflection. Call this image A. They're a little bit ambiguous here. Is it that they want me to translate this? Because if I translate 1, 2, 3, 4, nah, it can't be this. It had to be this. Because if I translate this 4, 7, it's going to be off the graph. So it have to be A. There was a little bit ambiguous there. If it was the first one, then the second one. But all right, so this is A, and we're going to go for A double prime. So 4, 1, 2, 3, 4. And then -7. So 1, 2, 3, 4, 5, 6, 7. That is the point I end up there. That was this point that I took, and I translated it 4, -7. So that point will be here. So that means that we'll have this shape here, like this, like this. This is A double prime. This is the translation from A to A double prime of 4, -7. Okay, that was it. All right. Well, I hope I'll get that for the exam. That was real easy. Yeah. Consider the following functions: the f of x, the g of x, and the h of x. For what value of f of x, what value of x is f of x undefined? So for what value of x is f of x undefined? The only way that we just get undefined is when you have something divided by 0, right? So we could see f of x, we don't know the answer to this question. Yeah, this question is undefined, right? So for f of x to be undefined, that means that we have the 3 in the numerator, but the denominator will have to be 0. And that is when f of x will be undefined. And what will make the denominator 0? If x is equal to -2. So if x is -2, -2 plus 2 is 0. So x cannot be, therefore f of x is such that x cannot be equal to -2. Find the value of the g of a quarter. So we have the g of x is 4x minus 5. Thank you, Csec, for putting such easily doable fractions. That is 4 multiply by a quarter minus 5, which this and this, that gives us 1 minus 5. So that means the g of a quarter is going to be 1 minus 5 is minus 4, negative 4. Let me know if I'm doing anything wrong. The h of negative 3, what is h? X squared plus 1. So the h of x is x squared plus 1. So the h of negative 3 will be negative 3 squared plus 1. So 3 3s are 9. That's positive 9 plus 1, which is 10. The f of 0. So the f of x, first of all, is 3 over x plus 2. Let me just write that on the side here. F of x is 3 over x plus 2. So first I have to find the f of 0. So the f of 0 will be 3 all over x. 0 is x plus 2, which is 3 over 2. Right? So therefore, the f of 0, right, is the f of 0 is 3 over 2. Right? So we kind of coming into a little bit of fraction-y kind of things here now. So we have 3 all over 3 over 2 plus 2. How about, instead of saying 2, I could say 4 over 2, because 4 over 2 is 2, right? So because I could say 4 over 2 means I now have 3 all over, 3 and 4 is 7 over 2. So when you are dividing by a fraction, you flip the fraction and multiply. So 3 over 1 divided by 3, that's 3 multiplied by 7 on 2, 3 2s are 6 on 7. 3 multiplied by 2 on 7, sorry. Write an expression in its simplest form for the g to the h of x. All right. What is, somebody tell me what is g of x, please? G of x is 4x minus 5 and x squared minus x squared plus 1. If I get it wrong, it's because earlier. 4x minus 5 and x squared plus 1. Thanks for nothing. Right? Let me see. The g of the h of x, so that means that we are taking the h of x and putting it inside of the g function. So the g function is what we're working with, and this is going to go inside here. Right? So that means we'll have 4 into x squared plus 1. This is 4x minus 5. This is the g function. The h function is inside of the g function. This is actually how the world around you operates. This is not just algebra on a page. This is actually the code for the matrix. Yeah, serious talk, right? So therefore, the g of the h of x is 4x squared plus 4 minus 5. So the g of the h of x is 4x squared minus 1. Wasn't so bad. So I had to find g inverse now. So g of x is 4x minus 5. So first let y equals 4x minus 5, and we'll make the x the subject of the formula. So therefore x is y, and I throw in across the 5, so it will be plus 5, and then I throw in across this 4, so all of that will be divided by 4. All right, and then swap x and y. Implies that g inverse of x is x plus 5 over 4. Therefore, the G inverse of negative 2 will be negative 2 plus 5 over 4. Negative 2 plus 5 is 3 over 4. So moving on, we have they bring a bar graph question. They didn't bring a cumulative frequency question. Well, that means all you're gonna get a cumulative frequency question for sure. Yeah, for sure. Let me see if January had that. Each of 75. I'm done tired already. Each of 75 girls recorded. All right, so 75 girls we're dealing with here recorded the name of her favorite sport. All right, thanks for the English. The number of girls who chose track and cricket are shown in the bar below. So I have 12 here for track. I have 17. We'll call it 17 for now. 16, 17, 18, 19, 20, I guess. Yeah, 17-ish. All right, for cricket. And I guess I have other sports here, and all of that has to add up to 75. So 12 plus 17 is how much? 12 plus 17 is 29. So far I have the 29 out of the 75. All right, so I wonder where the others, let me see where the others are. How many more girls chose cricket than track as their favorite sport? Cricket than track. So that'll be 17 minus 12. 5. All right. 11 girls recorded tennis as their favorite sport. Stop. I needed visual. Tennis, go in here. 11. So this is tennis. This is 11. So now all three of them is 29 plus 11. So now we're dealing with 40 out of the 75. All right, let me see what they were with these 11 now. 11 girls recorded tennis as their favorite sport. For the remaining girls, all right, so how much is the remaining girls? So remaining, let me call it R. 40 girls so far out of the 75. So that's 75 minus 40 is 35. So the remaining girls is 35, all right? For the remaining girls, the number who chose swimming compared to football is to the ratio 2 to 3. So that means that swimming to football is of a ratio 2 to 3 for the remaining, which is out of 35 students. So for 35 students. So that means that out of 35 students, right? Remember, with this kind of ratio, you add 2 and 3 is 5. So that means 2 out of every 5 students chose swimming, and 3 out of every 5 students chose football, right? So use this information to complete the bar chart. All right, so that means that swimming will be 2/5 of 35, which will be 14. So swimming is 14, and 35 minus 14 is 21. So I have 21 football here, 11, 12, and 17. 11, 12, 17, and just to be sure, I'm gonna add those numbers up to see if I get 75, right? So 14 plus 11 plus 12 plus 17 plus 21 is 75. So looking like a good to go day. And of course 14, they say use this to complete the bar chart. So 14 could be here-ish. and football is 21. So 21 is the most popular sport, definitely football. We have any footballers in the class? Yeah, I think I had known that about you, Ali. One of the girls is selected at random. What is the probability that she chose neither track nor cricket? So she didn't choose track or cricket, right? So the girls, all right, so the probability of no track or cricket, all right? That is track is this 12 and 17. So those who did not choose track and or cricket is these guys here. That's 14 plus 11 plus 21. That's 46. So 46 girls did not choose track or cricket. So the probability of picking somebody who didn't choose track or cricket would be the 46 out of the total 75, which is 0.61. A little more than half the chance. Right? The information on the why does this question never end? The information on the favorite sport of the 75 girls is to be shown on the pie chart. Did I miss a question though? Yeah, look, I miss here. Determine the modal sport. The modal sport is the most popular one. That is football. All right. What they're asking us here, the information on the favorite sport, which is football, which is 21. No, that's the modal, but not necessarily the favorite. Of the 75 girls is to be shown on a pie graph. Calculate the sector. Yeah, all right. So it is football is the favorite sport. That is the modal sport or the most popular, 21. So that means that 21 out of 75 girls, this is the biggest chunk of the pie chart. And imagine you have a pie chart. A pie chart is 360 degrees. So what fraction of this is going to take up football? Well, it'll be this fraction. It's this fraction of 360. And that will give us 21 divided by 75 is that. Multiplied by 360 is 100. 100.8 degrees. So therefore the calculate the sector angle for the football. So, oh, look, they even tell you it's football here, the favorite sport. So so that is, so if this is 90 and this is 180, like 108 degrees might be looking so-ish. 108 degrees football. They didn't tell you to draw a diagram though, eh? So you didn't have to. But sketching is always great. Please leave your sketches, leave your scribbles and all of them kind of things, because you never know when a scribble could give you some marks. So leave your sketches, do your scribbles, do your thing. Right, so we have this question. Pi, the volume of a cone with radius r and height. So you see, they don't expect you to remember all of this madness. They gonna give you the harder ones. They gonna give you, right? The diagram below shows the sector OMRN of a circle with center O, radius 12. So that means this is gonna be 12 as well, and the sector angle is 168. Right? Which was formed using a thin sheet of metal. So I guess they're gonna form a cone with this, because I see they're talking about cone here. You could tell that this is the net of a cone. If you bend it together, you'll form a cone. Calculate the perimeter of the sector. So the perimeter of the sector is the distance around. That'll be this 12 plus this 12 plus this distance. This distance, well, we know the circumference of the full circle will be 2 pi r. That is the circumference of the full circle. But we don't want the full circle. We want this fraction of the circle, which is this angle here. So that will be multiplied by the fraction 168 over 360. So therefore, C is equal to, let me see, 2 times 22 over 7 times R, which is 12, times 168 over 360. Anybody want to help me with this? No? I guess I had to do it. 44 divided by 7. I'll use brackets. Times 22 over 7 times 12. O ye of no help. Times 168 all over 360. Y'all are horrible, boy. Y'all are horrible. Like, I'm beginning to resent all your thing. Well, not really, but 35 and 1 over 5. Right? So 35 and 1/5 centimeters, I guess, is this length here, 35 and 1/5. Right, so calculate the perimeter. So we still have to find the perimeter yet. So the perimeter will be the 35 and 1/5 plus the 12 plus the other 12. So 35 and 1/5 plus 24 is 59 and 1/5. For those of you who did the question, please let me know if I'm making any mistakes or anything like that. Right, so now they make the cone, right? So the cone, you see this area here, the radius, this radius here, when they bend the radius together, imagine, and maybe I shouldn't do it with it. Imagine these are the two radius and they bend it together like this. Right, those two radius is forming the slant side of the cone. Yeah, so we could know that the slant side of the cone here is them radius. So the slant side is actually 12. We know that. All right. This here, which is 35 and 1/5, when we squeeze the cone together, this curved side is what is forming this circle over here. So the length of that bottom circle, the circumference of that circle, will be 35 and 1 over 5 centimeters. All right. Calculate the radius R of the cone. So we have the circumference. So the circumference is 2 pi R, and that is equal to the circumference being 35 and 1/5. So now R will be 35 and 1/5 divided by 2 pi. 5 and 3/5. Zara, you reach here? 5 and 3 over 5. This slant side here is 12. Right? And so we could actually use Pythagoras theorem to find h, right? So h squared plus r squared is equal to the slant side 12 squared, right? So h squared plus the r squared is equal to 12 squared, right? H squared is equal to 12 squared minus the r, which is 5 and 3 on 5 squared, right? So h squared is equal to 12 squared minus 5 and 3 on 5. Holy crap. All right. 112.64, right? So h is going to be the square root of 112.64, which is
10.6.
All right. Well, thanks for helping me with like the easiest one. Yeah, I appreciate the effort. 10.6 centimeters. Calculate the capacity of the cone in liters. So this is where we have to use this formula, 1/3 pi r squared h. So 1/3 pi r squared h, and that is the volume. So therefore that is a third times pi times r, which is 5 and 3 on fifths. You know what? 5 and 3 on 5 is 5.6. I'll use 5.6. 5.6 squared, and h is 10.6. Interesting. So, all right, 5.6 squared times 10.6 times 1 on 3 times, and I use in brackets there, 22 over 7. I really wish that you guys could see, like when I type it in my calculator, it's showing up there. I could use the scientific calculator on the browser, but it's just not the same as this, which is the ones that you just use, right? Where you get Zara or Sabira or Anya. Anya, you do the paper? Anybody who's supposed to do the paper?
I get 348.2.
Yep. That's why I got to 348.2 centimeters cubed. All right. So we reach number 7. All right. Yeah. Maybe we'll finish before 8. I think liters is. Huh?
Yeah, 0.348.
Oh yes, centimeter cube, and a liter is, oh wow, damn bro. So that means that is a real easy mark I would have lost there remembering that conversion, because this is centimeter cube, and to convert to liters you had to divide by 1,000. So that would give 0.3482 liters. Is that the final answer?
Yes.
Damn, look how I clear forget about that inversion. I would have lost that marker real easy. Yeah, that conversion. A sequence of designs, and thank you very much for assisting me pointing that out. Yeah, I totally missed that, but that is why I hope that you all would do the questions and stuff. To help me out a little bit now. A sequence of designs is made using black discs and white discs. The first 3 designs in the sequence are shown below. All right, I see in there, and of course they're gonna ask for the 4th one. So I see in here that they're just adding on. So you're gonna have 1, 2, 3, 4, 5, and then you have. All right. Well, I could see that they, since earlier was so adamant about the space between, they have 2 between. So I'll leave the 2 between. 1, 2, 3, 4, 5. Then they have a clear one, and then. Ooh, so this one is 1 more. So 1, 2, 3, 1, 2, 3, 4, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6. And then all of these will be clear. All right. So the space, in the space provided on the grid above, draw design for. All right, we just did that. The number of white disk W, the number of black disk, the total number of disk T form each design follow a pattern. Yes, we see that. The values for blah 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 are shown in the table below. Study the pattern of numbers in the table. Okay, you could see here in this question we need to figure out these sequences first, and then we could figure out anything else. We could see here that we have n on this side. So n here being 1, 2, 3. I could see n here being 1, 2, 3. So there, 1, 2, 3. And then n again, 1, 2, 3. Plus n again, 1, 2, 3. So that means that n times n plus n plus 1. So that means n times n is n squared. So this will be n squared plus n plus 1. And you can see here you have your n squared plus n plus 1. So here, therefore, this n will be 20, obviously. This will be 9 plus 9 plus 1. So 9 nines are 81. 9 times 9 is 81. Plus 9 plus 1 is 91 over here. All right, let me see this one now. 4, 6, 8. So I guess I had to do this the old-fashioned way. So we have the sequence here, 4, 6, and 8, where n here, this is n is 1, this is when n is 2, this is when n is 3. So what can did anybody get through with this? Anybody want to tell me? Anybody reach the sequences 1? All right.
Edward, 2
All right, so 2.
n plus 2.
Right, yeah, okay. So thankfully, because the first thing I would have tried is 2, I would have said, all right, multiples of 2. So 2 times n, and 2 ones are 2, and I'd have to add 2 to give me 4. So 2 times 1 is 2, plus 2 is 4. So 2 twos are 4, plus 2 is 6. 2 threes are 6, plus 2 is 8. So therefore for n, or for n in this case here, it'll be 2n plus 2. So this here is 2n plus 2. So that means for 20, that will be 20. 2 times n plus 2. 2 twos are 4, so that's 42. Over here will be 2 times 9 plus 2. 9 twos are 18, 19, 20. All right, let me check this one now. Ooh, 7, 13, 21 prime numbers. I see when n is 1, n is 2, n is 3. Well, I would try, I see, and maybe this look like a squarish kind of scene. But let me try 6. 6 times 1 is 6, plus 1 is 7. 6 twos are 12, plus 1 is 13. All right. 6 threes are 18, plus 1 is 19. So you see, it worked for the first two, didn't work for the third one. So it's not 6, right? And we just trying other random things. What about if I square n? So 3 threes are 9. 2s are 18, 19, 20, 21, plus 3. Let me see if it works here. 2 twos are 4, 2s are 8, 9, 10, 11. No, it doesn't work there. All right. Anybody figured out this one?
Sir, keep that, but you multiply it by 3.
Oh, so it's n squared by 3. Yes, okay. So thank you for saving me.
No, sir. It's 2n plus n squared plus 3.
2n plus n.
3n.
3n. 3n squared.
No. 3n plus n squared plus 3.
Damn. This would be a tough one. It would have taken me a while to try to. How long did that take you to figure out?
A half an hour.
A half an hour. Yeah, boy. This one, yeah. In a case like this in the exam, this is where you leave this out and move on, eh? This is the one that you would leave out. If you find it taking you too long, it's time management. So you can't stick for a half an hour inside of that exam. No way, right? So once you find you're sticking for more than 5-10 minutes, move on. Yeah. Yeah. Because you see, this thing is trial and error, and this thing really, I mean, it really wasn't that fair, honestly, because this is quite a tough. Because you're dealing with prime numbers here, so it's, it's tough to see. It's tough to see because look, she had to go 3n. So I wonder, is this? Did you get that answer from like a paper, solutions paper or something?
No, sorry, the trial and error.
Trial and error. So 3n plus n squared plus 3. Zara, did you get this one?
No, I didn't like get the last row.
All right. Okay. So you didn't get this one. Let me see. Let me see if I can find. Let me see if I can find anything simpler, maybe. Um, because if n squared is involved, right? Three trees are 9, trees are 27 minus 6. Alright, so 3 trees are 9 times 3 is 27 minus 6. 2 twos are 4, trees are 12 minus 6. Certainly doesn't give you 13. Damn, I could see how this could keep you back for a while doing the trial and error on this. This is a kind of wicked question, boy. This is a wicked question. I wonder if I could find a different version. I'll just try 2 more times and I'll see, and then I'll just go with Siberia's answer here. Let me just see. 3 times, so 3 trees are 9. You go on, and how you even? So you would have had to go 3n. 3 trees are 9. How you even? How you, Sibira? How you even come up with this, yo?
Okay, what I did first is that I tried to make the numbers even. So I had 6, 12, and 20.
Right.
And I now worked from there.
Right. Interesting. So you work with 6, 12, and that's an interesting strategy. That's a very interesting strategy. Okay. All right. So we'll deal with this. 3n plus n squared plus 3. That one is a crazy one, boy. Right? So what you would have done was you would have go 3, 6 trees are 8. No. 3 ones are 3 plus 3. Oh, and I see what you do here. 3 twos are 6, 7, 8, 9 plus 3. And 3 trees are 9 plus 3. No, oh, then you would have had, interesting, boy, interesting. You know what? I think that it have an easier answer. Yeah, Sabira, I'll go with your answer, but I will actually sit down and try to work this a little bit. I just wouldn't do it now because of the time constraint, right? But I think it have an easier answer. I think so. So what, you tried like 1, 2, 3, 4.
Yes, I did.
It have usually when you see this is just now it bothering me now. All right, it bothering me now, right? 8 ones are 8 minus 1. You try all that. 8 twos
No, I
are
didn't go to 8. It's
8
up to 6.
8 twos are 16 minus you know what? If you had done 7, you would have seen a pattern. Alright? If you had done 7, you would have seen a pattern. Check this out. 7 times 1 is 7. 7 times 2 is 14 minus 1. Right? 7 times 3 is 21. 7 creates. Alright. Alright, Sabrina. I'll go in with yours. But I sure it have an easier answer here, so I'll definitely dig into it, and I'll probably let you all know in the next class what I'll come up with, right? But I sure it have an easier one, or maybe not. Maybe Sibira really have it, right? Cause yeah, boy, to come up with this Sibira, yeah, boy, Yeah, I would not think to do the 3n and then do a next n squared. And I would not never think of that. That is crazy. This is a crazy question. And then, but thankfully, if you didn't get it, you would have only lose these set of marks here. Ooh, look, they had another one. Look, 9. Look, I had a 9 here. When n is 9, you have 111. So they actually gave you another clue. And that's another prime number too. So all prime numbers here. This is a curious question indeed. All right. So 3 times 20 plus 20 squared plus 3. Where does you end up get here for this one?
463.
463. Yeah, and it seems to be going with it. Let me just see for this 9. So 9, so 3, 9 times 3 plus 9 squared plus 3. Yeah, it worked. 111. All right. Yeah. I sure it'd have a different way though. I sure because Csec cannot expect you to dwell for half an hour on that. All right. So I will look for an easier way and I'll come back to you next class. But thank you very much, Sabira, because I hope I would have. Maybe if you didn't tell me that, I would have found it. I don't know. But the strategy is you try 1, you try 2, you try 3, you try 4, then you try squares. I think I would have tried some higher numbers with the squares. But you see this 7 here. Because 7 nines, 63. And you would have had to add 48. All right. That's how. All right. Anyways, moving on. Excellent job, Sabira, though. Like, wow. Stefan has 28 black discs and 154 white discs and wants to make design 12. Explain why it's not impossible for him to make design 12. So let me see how much white discs he has. He has this. And the number of black discs he has this. So you have what? 150, 28 and 154. So 154 here and 28 here. He want to make 12, design number 12. But for design number 12, we would have to have 12 squared plus 12 plus 1. Which is 157 white discs. And we would have had to have 12 twos are 24. 12 times 2 is 24 plus 2 is 25, 26. 26 black discs. So this is the reason why we can't use this. It's not possible to make. We do not have enough white discs and we have too much black discs to make design 12 from this. We just don't have enough white discs. So that's easy. That's a 1 mark. All right. Algebra number 8. Let's see. I guess we had to go a little bit over 8. If you can stay with me, please feel free. If you have to leave, please leave present in the chat so that you'll get your name on the roll. Please do that. Do not leave without getting your name on the roll. That's very important, right? Otherwise, I'm going to be telling all your mother, hey, this man don't come to class and thing. So just put present in the chat if you have to leave. But we might go a little over 8, right? Just a little bit. Complete the table for the function this. All right. So y is equal to negative x squared plus x plus 7. So negative x is negative 3, yeah? So you're putting x in the bucket, negative 3 squared plus in the bucket, negative 3 plus 7. So this is 3 threes are 9 in the bucket, but you had the negative outside, minus 3 plus 7. So that is negative 9 Negative 9 minus 3 plus 7 is negative 5. So we will have negative 5 here. I have a feeling we're going to have, oh no, look, I see negative 5 on this side. So that's interesting. So that means that the line of symmetry is not the origin. All right. So let me check for negative 1. So we'll have negative 1 squared. Oh, minus. You see, minus x. Minus x squared plus x plus 7. So this will be negative 1 minus 1 plus 7. So negative 1 minus 1 is negative 2 plus 7, which will give us 7 minus 2 is 5. And no. Negative x squared. So negative 1 times negative 1 is positive 1. And you have this negative on the outside D. Then you have the negative here. Am I making a mistake, guys? Plus negative 1 plus 7. Am I making a mistake, or did you guys get this? All right, let me see.
That's supposed to be negative or positive?
Which one? I see a negative x squared here. All right, negative 5. Oh, that's the y. So if it's the y, then it'll be going negative 5. Then it'll be going 1. Then it'll be going 5. Then it'll be going 7. And then it'll be, all right, come back down 5 and then negative 5. Okay, no. I guess it looks correct to me. All right. All right, it looks correct. All right, so this will be 5. Oops. 1, so that's negative bucket 1 squared plus bucket 1 plus 7. So that's negative 1 plus 1 plus 7. So that will give me 7. And then this one here is 3. So that'll be negative bucket 3 squared plus bucket 3 plus 7. So that's 3 3s are 9, negative 9 plus 3 plus 7. Negative 9, oh no, negative 9 plus 3 is equal to negative 6 plus 7 is 1. Yeah, because if we go 5, 7, 5, 1, negative 5. Yeah, that's correct. All right, and I guess we had to plot it on the grid. Plot the graph for between x is negative 3 and x is 4. You're seeing that here. So negative 3 and 4. So we have that there. Somebody want to call out the points for me, or or are you gonna make me flip from page to page?
Call x first and call like
X first, yeah. So x is negative 3. Y is what?
negative 5.
So y is negative 5. That is here. X is negative 2. Y is
1.
1, positive 1, right? That's there.
Yeah.
X is negative 1. Y is
Positive 5.
positive 5. X is 0. Y is
7. Positive 7.
and then and next 7 when x is 1.
Yeah.
All right, and then when x is 2, you're gonna have another 5,
Yeah. And then 3 is 1.
and then 4 is negative 5.
Yeah.
Yeah, we could see the line of symmetry here. All right, and in fact, let me draw, before I show you the line of symmetry, let me draw the actual thing. You have to be real careful here. And I mean, I did a horrible job at drawing this thing. You had to be much carefuler. In fact, let me try to draw it a little better. I think I just use that. All right, let me try a little better there. Drawing it on this pad is not easy now. So no, all right. Is the pad, right? Is the pad. But you get the point. You just have to be real careful. Write down the coordinates of the maximum and minimum point of the graph. Well, that is this here, right? Now, if you draw it carefully, and I'll just draw over this part here, because my pad is real hard to average, because I'm looking so, and my hand there, you know, so it kind of hard to the average. So I'll just try to draw this part real good. So you have this part there, this part there, and it will cut across like that, right? So maybe, because it's an estimate, so we could make it like about 7.5-ish, right? So this here looking like about 7.5 on the X, no, on the Y, and about 0.5 on the X. All right, just now, let me write that a little better. This here is 0.5 and 7.5. All right, so 1/2 and 7.5. Any questions? Please feel free. Write down the axis, the equation of the axis of symmetry. So yes, we was talking about the axis of symmetry passing through this point here. It will be the line x is equal to 1/2. X is equal to 1/2 or 0.5, but we prefer use fractions in this case. X is equal to 1/2. That is the line. Use your graph to find the solutions of the equation is equal to 0. Well, they're talking about the roots here. And the roots here would be this and this. And just for the sake of the question, I'll try to draw over that part of the graph a little accurately. It's super hard to do. And we could see here, I don't know, what is that? 3.12345. So that's 3.2 on this side here. And then on this side here, I have -2.2. All right, so the roots there are x is equal to -2.2 or x is equal to 3.2-ish. And yes, there is a margin of error. On the grid on page 24, draw a line through those points. All right, so I had to draw a line through the points. -3.1, you know what? I had to draw over this thing, you know. All right, you know what? I'm going to bite the bullet and draw this thing nice and neat, because they're going to ask me to, all right. They're going to ask me to solve a equation, a simultaneous equation. So -3, so we have 2 points here, -3 and -1. So I'll do that in red maybe, even though please do not use red. -3 and -1 is this point here, and 0.8. 0.8 is this point. Ooh, this looking like it might be a tangent kind of thing. 0 on the x, 8 on the y. Let me actually join it by a straight line instead of trying to draw a straight line. Yeah, boy, it's very tangent-ish. It tangent-ish. Right by this point here. Right by this point here, which is the point -1, 5. I'm just making a note of that. Let me see if they ask me for that. Right? Determine the equation. They didn't even want what? Why did they tell me to draw it on the grid? If they didn't want, all right. So they just want the equation of the line, right? Now the equation of the line, y is equal to mx plus c. You can see that c is 8. We could see that on the graph. That's where it cut in the axis. And we could do the y2 minus y1 thing, but because we have a graph, means that we could just find a nice triangle. So, this is a nice triangle. Remember, is the rise over the run. So the rise here is from 2 to 8, which is 6. And the run here is about 4. So we have the rise, which is 6 over 4, which is 3 over 2. So the gradient of this thing is 3 over 2. So y is equal to 3 over 2x plus 8. Any questions? I know I'll be halfway sleeping by now. I wonder if anybody actually still paying attention, boy. I don't know. Here we go. This circle theory question wasn't that bad though. They want to find the angles R, the angle E, the angle A, and that is it. Right? And so if we look at it here, you could see that this is the angle R. They want to find this first. The angle E, they want to find this second. And the angle A, they want to find this third. Right? Let's see. Let's see what we have. I could see this is a radius, and this radius is meeting a tangent, so that means that this is a 90 degrees. All right, maybe that helps me, maybe it doesn't. I could immediately see that this chord here is subtending the angle R, and it also subtending the angle at the center, which is twice the angle R. So immediately I could see that the angle R would be 156 divided by 2, because the angle at the center is twice the angle of the circumference when subtended by the same chord. And so 156 divided by 2 is 78. And they say they want the reasoning, so I will put 156 divided by 2 is 78, and this is angle R degrees, because the angles at the center are twice angles at the circumference when subtended by the same chord. All right, then they want what? Angle E. Well, all right, so if this here is 78 degrees, I could see here that the angle E, this 78 is subtended by this chord. And the angle E is the angle between the tangent and the chord. And the angle between a tangent and a chord is equal to the angle subtended by that chord. So this is also 78 degrees. And so here I would put E equals 78 degrees. The angle of tangent and a chord equals the angle subtended by that chord. Please do not use red ink in your paper, right? Right, and then they want the angle A. So I could see that this here is a cyclic quadrilateral. If we notice, this is the quadrilateral here. Right? And because this straight line here is 180 degrees, that means this angle here will be 180 minus the 78 plus the 48. So this angle inside of the cyclic quadrilateral, this angle here will be plus 48. Thanks so much for the help, guys. 180 minus 126 is 54. If this angle is 54 degrees, then angle A is 180 minus 54 degrees. Why? Because opposite angles in a cyclic quadrilateral are complementary. No, sorry, supplementary. Alternate angles in a cyclic quadrilateral are supplementary, meaning they add up to 180 degrees. So 180 minus 54 is 126. So this will give you 126 here. And of course, you could put the reasoning I would put for that and how I would write the answer for that. And let me just put how I would write the answer for that. I would write MLRN is a cyclic quad. Right? Therefore, angle NRL, which is this, is equal to 54 degrees, and the reasoning being angles on a straight line. That's all you had to put. Right? And then therefore angle A, the angle A is equal to 126 degrees, and then you'll put your opposite angles in a cyclic quad are supplementary. The diagram below shows a triangular field LMP. It's really 804. All right, I had to go to the end, yeah, guys. So whoever want to stay could stay, and if you can't stay, no problem. But I had to go all the way. All right. The diagram below shows a triangular field LMP on horizontal ground. All right. Calculate the value of the angle MLP. MLP is this angle here. Yeah, this is a straight up cosine rule. Yeah, this is a cosine rule. This is, remember how we, if this is the angle P, this is the side P. This is the angle L, so this will be the side L. This is the angle M, so this will be the side M. And what do we want to find? We want to find the angle L. So that means we have to use the formula with the side L as the beginning. So L squared is equal to P squared plus M squared minus 2PM times the cosine of the angle L. And this is how we're going to find it, right? So L squared is 180 squared. Yes, these cosine rule questions often have these very, very big numbers in them. That is, P is 120 squared plus 150 squared minus 2 into 120 times 150 times the cos of L. So now we just have to boil it down. So 180 squared is 32,400, and that is equal to, I'll work this out, 120 squared. And of course, if you did work it out already, please help me out, right? This is 36,900 minus, I'll work this out, 2 times 120 times 150 is 3,600 times 36,000 times the cos of L. So this is a multiply here. So you can't subtract these two. But what you could do, let me come on this side here, is I could say that negative 36,000 cos L is equal to, if I take this and throw it across, I will get 32,400 minus 36,900. And so the cos of L will be the answer for this, 32,400 minus 36,900, which is negative 4,500 divided by negative 36,000. So divided by negative 36,123, and therefore L will be the cos inverse of 0.125, which is the answer for this. So L will be, the cos inverse of the answer is 82.8 degrees. I think this was the hardest part. The bearing of P from L is 210 degrees. So the bearing of P from L, so we're going in this direction, we're traveling from L to P, right? The bearing, this bearing here has to be measured from the north line in a clockwise direction. So this is 210 degrees. So if you turn the ship around 210 degrees, you're going to be heading towards P, right? And immediately I could see here that, that this angle here is 82.8 degrees. So I have a feeling I know what's coming. Find the bearing of M from L. M from L. So if I'm going from L to M, I'm going this way, the bearing there will actually be this angle here, right, to go towards M, and that will be 210 degrees minus 82.8, which is 127.18 degrees. So that is 127.18 degrees. 127.18 degrees. Calculate the value of the angle NLP. NLP. So NLP is this angle here. NLP. Right? And hence, find the bearing of L from P. So L from P means you're going back in this direction from P. So that means that this is the north line here, and you actually want this angle. So from this north line, you want this angle to go back to L from P. So this angle over here will be 360 degrees minus 210, 50 degrees. This angle here, remember that these two north lines are parallel. So these north lines are parallel, and so this, we have co-interior angles. So co-interior angles are supplementary. So 150 plus 30 will give me 180. So that is 30 degrees. And of course, all of the working that I had up here is what you would have put, you know, this working, and this is what you would have put here. Any questions on this bear? This was a pretty easy bearings question. I hope you get a bearings question like this. Right, vectors and matrices. Now this was quite a surprise, right? This is the first time I ever saw them bring this topic. And honestly, this is a topic that I missed. I missed this topic in the videos that I had left for you there. You know how when we were kind of rushing to finish in time to start past papers, so in that rush, I actually missed this topic. So especially for those exam students, you might want to take a note on this. It's a very simple topic. It'll take me a minute to show you, but this is the topic that is called composite transformations. It's a very easy topic, but it does have one rule that you have to know. Just one rule, right? So in the melee of trying to rush down things, we missed this one, but it'll really just take a minute. It's quite easy, but it's just a rule, an important rule you have to know. So these are the matrices A and B. A represents a rotation of 90 degrees about the origin. So this represents some transformation, is a rotation, right? This one here represents a reflection, right? So a reflection in the line y is equal to negative x, right? They say determine the elements of a matrix C, right? So we want to find the matrix C, which represents an anticlockwise rotation about 90 degrees. Anticlockwise rotation about 90 degrees is matrix A. So first, you have a matrix A, so you have whatever shape, and the first thing that you have is the anticlockwise rotation of 90 degrees. So that is the matrix A first, followed by, and then you will have a reflection of the straight line, which is the matrix B. So this is what composite functions is all about, right? When you have one function, and composite functions, composite transformations, yes, they are the same thing. We essentially doing composite functions here, but we're just doing it with matrices, right? And what we're saying is that this matrix or this function does something. In this case, it rotates 90 degrees. And then we want to do this, which is reflect in that line, y is equal to minus x, right? So we want to do this, then this. So when we combine, so when we want transformations, A, then B, right? So A, then B, we actually have to flip it around. So the matrix C is the matrix B multiplied by A. And this is the rule, yeah? The rule is if you want to go from A to B, right? And this is not, these are two different transformations. So you want to combine these two different functions, right? What they say is to multiply the two of them, but flip it around. Multiply the B first and then the A. So it's a real simple little rule here that you have to know. And we just missed it, but thankfully we got it, right? Trust me, you see this? You're not getting this in your exam, for sure. For sure, this is not coming for you, but it's a good thing. This is the first time I've ever seen this little rule in an exam. First time, right? All right, so therefore the matrix C they're looking for is a combination of these two things. So I have to take the matrix B. This is the matrix B, and multiply it by the matrix A, which is 0, negative 1, 1, 0. And that will be, well, first I will take this row and multiply it by this column. So I have 0 times 0 is 0 plus 1, negative 1 times 1 is negative 1. Then I'll take this row and multiply it by the second column. So 0 times 0 is 0 plus negative 1 times 0 is 0. Right? I could tell here that this row by this column is going to give me 0. 0 times 1 is 0. And then I could tell this row by the second column will give me positive 1 plus 0. And so the matrix C ends up being negative 1, 0, 0, 1. Now they asked you, right? And I just kind of want to show you something, right? In terms of this. When we just in case you was trying to figure it out, it would have had to have been a multiplication in some way. You had to multiply these matrices in some way. You only ever add matrices when you are doing a translation, right? So if we look back here at, remember with transformations, I gave you this little cheat sheet, and you notice here how, the object, right, wants to move under this transformation in order to give you the image, and usually you put the transformation first. Yeah, you will usually put the transformation and then the object, but in this case we just had two transformations. But I wanted to remind you of this because of what we have next here, right? Describe geometrically the single transformation by C. Now here's the problem. I didn't bother to learn off all of these matrices that I show you here. All of these matrices for reflection. Look at all of them there. And then, the rotation. Look, these are reflections again, and I have rotation somewhere else. I didn't bother learn off all of these matrices. So I don't know, boy. What am I going to do? Because I didn't learn it off and I didn't put it on my cheat sheet. So is there a way I could just look at it and kind of figure it out? Well, maybe, right? They want to know what kind of a transformation is this? What kind of a transformations we have? We have reflections, we have rotations, we have translations, which is probably not a translation, right? Reflections, rotations, translations, and enlargements. This is not an enlargement because you would have seen, like 2002, you would have seen something like this if it was an enlargement, right? So it had to be a rotation or a reflection, but how do I figure it out? Because I forgot to learn all of that stuff. Well, it actually is pretty easy. Just remember, this represents your x values. So in this case, the transformation here, x is negative. This represents the y values. So in this here, the transformation, x is a positive 1. That means that if you had an image, or like say an object, say the object is the point 2,3, right? Remember, this is the x and the y value. So you could see here that, if you undergo this transformation, the x value will be affected. You're going to end up getting a negative 2 for the x value, but the y value wouldn't be affected. The y value here, you'll still have your normal 3. So that means that if you look at it on a graph, let me just say you have this here, 2, 3. Let me just say that this is the point 2, 3. Right? And you put the point through this transformation, you'll see that my y value is not going to change. My y value is going to remain 3. Right? Because the y value, you just have a positive 1 there, so that's not going to do anybody anything. But the x value is going to change. You can see that my x value is going to become negative 3 on this side. So it's easy to see in this case that we're dealing with a reflection in the y-axis. So a reflection in the y-axis, or that is the line x is equal to 0. So you could see here that even though you didn't learn off that long list of transformations, you didn't learn off that long list there. So how do you figure it out? Well, you could actually use your common sense and a little bit of understanding of the topic, and you should be able to figure it out there. And once you understand the topic a little bit, And you know that, hey, these are the ones that affect the x value. These are the ones that affect the y value. Yeah. So that's how that happens. Let's see. The transformation T is defined by this 2 by 2 matrix, right, where K is a constant. This maps on this point, which is the object, to the point this, which is the image. Right? And remember, we saw for any transformation that you had to take the transformation first, multiply it by your object, and that is where you'll get your image. Yeah, so you take your transformation first, which is 1, 2, k negative 1. You multiply it by your object, 2, 3, and that is what will give you your image 8, 15. Right? And so you can see here, let's check if it's correct. 1 times 2, that'll give me 2. Right? And then 2 times 3, that is plus 6. So 2 plus 6 is 8. Yes. And in this case, we have k times 2. So that is 2k plus, this is negative 1. So yes, negative 1 times 3 is negative 3. So this 2k plus negative 3 is what will give me this answer, which is 15. So therefore, 2k minus 3, it will be equal to 15. 2k is equal to 18. K will be 18 divided by 2, which is... Any questions? No. You could see here that this was quite a surprise question. Right? As I said, they don't usually bring transformations. Transformations in matrices is like 1 in every 5 exams. Right? If they do bring transformations, they'll bring it as a little piece of the question. They usually never bring an entire whole question on transformations in matrices. So I'm pretty confident that you guys will not get transformations. You guys, let me tell you what you're going to get. You're going to get simultaneous equations, or you're going to get singularity, right? There are a singular matrix to find the inverse of a matrix. Remember, and to find the inverse of a matrix is 1 over the determinant, and you had to remember a singular matrix doesn't have a determinant, because one, so it wouldn't have oh god, the determinant is a singular matrix, the determinant is 0, and therefore it will not have a inverse, right? So that is what you're going to be getting. You're going to be getting simultaneous equations. You're going to be getting singular matrix in this exam coming up here, with determinant and inverse, and you might get one little piece that had to do with transformations. I doubt you're going to see any transformations in your paper, right? Because last year paper, the whole thing was a transformation, and then in January paper, the one that we just did, I think it had a little piece with transformations as well, right? So yeah, you ain't gonna get none. All right, vectors, and then we done. Let me see, is it 26? All right, yeah, at least we passed the exam in good time, right? 2 hours and a half, no problem. The following vectors are defined as shown below. That, and that. Determine each of the following. A vector other than 5, negative 1 that is parallel to WX. All right. So I want any one of these vectors that... a vector other than 5, negative 1 that is parallel to WX. They're not asking for these, are they? Because none of these are parallel with this. And you could easily tell. So a vector, they say a vector, right? So a vector parallel to WX is, if I just take 2 and multiply it by WX, 5, negative 1. That is 5 2s are 10, and negative 2. This is a vector, is parallel to WX. So remember how we check parallel and collinear is by multiplying by that scalar. So you could have multiplied by anything. You could have multiplied by 3, you could have multiplied by 5, and whatever vector you got would have been correct. All of them would have been parallel to wx. You didn't have to multiply by 2, you know. Wy, they want the vector wy. Determine each of the following a vector other than that is parallel to wx. They want wy. Yeah. You know what? I'm gonna draw a sketch because I need to see this thing. So I'm gonna draw a little sketch here. And this will really help you in a vectors question. Drawing a sketch. So I have 5 on the x minus 1 here. You know what? This is not the kind of sketch that I could draw actually. No, I can't draw a Cartesian plane sketch. I'll have to say wx, w, alright, 5 and negative 1. So wx gonna be kind of going like that. Alright, so 5 across and negative 1. So this is x. So this is 5, negative 1. Then they have xy, which is negative 3 this way. Yeah, and then 7 going down, which is all the way here. Right? So this is y. So this is negative 3 and 7. Right? And then yz. All right. So I guess it's not joining back then. So yz is 8 this way. From x to y is negative 3 this way, and then 7 up because it's positive 7. So this here is y. That is negative 3 and 7 going up. And then, so negative 3 goes back this way, and then 7 going up. And then we have yz, which is 8 going this way, and then negative 7 going down. So it's pretty much back down here. Yeah, 8 going this way, and negative 7 going down. So that is like this. That is like a huge long thing. That's crazy, right? And this would be y. No. This is wx. This is xy. Y to z will be minus this. So it'll be minus 8 going this way. And then negative 7 somewhere like that. So maybe it coming back by w, because this will be negative 8 and this will be positive 7. This is yz. I don't know. Let me see if that helps, right? Because zy going back this way will be 8, so, and 7. No. Just no, wait. Zy. If I'm making it going from z to y, I'm going 8 this way and negative 7 going down. So that means that z gotta be up here. Z. Because z to y is 8 this way and then negative 7 down. So that is z to y. 8, negative 7. Right, and y to z will be negative 8, which is this way, and positive 7, which is up. All right, so that is it. Let me see if that helps, right? This is w. They want wy. Yeah, it does help. So I could see here that wy goes from this to this. I could see here that wy is equal to wx plus xy. So yes, you see how a diagram really does help, but you have to be careful with this diagram, right? And I hope I didn't confuse anybody with my shenanigans there. It did confuse me for a little bit. wx is 5, negative 1, plus xy is negative 3, 7. And that will give you 5 minus 3 is 2, And 7 minus 1 is 6. So that is 2, 6. And that is it. This is, oh, for real? They have more? Okay. XZ. Holy crap. You can see here, we want to go from X to Z. So that means XZ is, and let me bring this diagram down here. No, I will take you and I will bring you. So they want XZ, and we can see here that XZ is XY plus YZ. So that is XY is negative 3, 7 plus YZ. And did they give us in that order? Oh no, they gave us in ZY. So ZY is 8, negative 7. YZ will be a minus in front of that. So that is negative 3, 7. All right. Plus negative 8 here, and this will be positive 7 here. So this will give us 7 and 7 is 14, and 8, 9, 10, 11, negative 11, 14. Yes, it looking like it could be that. The diagram could actually tell you. So you see how much the diagram did help us. Always, you see with a vectors question, if they don't give you a diagram, always draw a diagram. Last one, guys. XY, the modulus of XY. What is XY? XY is negative 3, 7. So XY is negative 3, 7. So the modulus of XY will be Pythagoras theorem, negative 3 squared plus 7 squared, and is the square root of all that, which will be 3 3s are 9 plus 7 7s are 49, and is the square root of all that, which is 9 plus 49 is equal to 58. Square root of 58 is 7.6. All right. I think that this was a pretty easy paper.